Lesson 7, angles between two lines. In the figure above, the lines PQ with gradient M1 and arrow S with gradient M2 make angles alpha 1 and alpha 2 respectively with the S axis. Line PQ made angle alpha 1 with the positive S axis, line S arrow alpha 2 with the same S axis. The angle between the lines is alpha. PQ S arrow. The angle between them is alpha. Previously, we have said that the tangent of the angle in non-vertical line made with the positive S-axis is equal to the gradient of that line. Therefore, tan alpha 1 is equal to M1 and tan alpha 2 is equal to M2. The exterior angle of triangle ABC, that is alpha 2, is equal to the sum of the two opposite interior angles, that is alpha 1 plus alpha. Hence, you have it in this form. We are interested in alpha. You transfer this angle to the other side, you have alpha to be equal to alpha 2 minus alpha 1. Hence, tan alpha is equal to tan alpha 2 minus alpha 1. From compound angles of trigonometry, recall that the tangent of the difference of two angles is given in this form. If you relate this to this, you simply replace A with alpha 2 and B with alpha 1 in this form, and you have this result. Tan alpha 2 is equal to M2 minus tan alpha 1, that is M1 over 1 plus the product of the two gradients. This becomes the angle between two lines. If this expression is less than 0, then the obtuse angle will be 180 degrees minus alpha. Therefore, the acute angle alpha between the two lines is given by tan alpha, the modulus sign or the symbol of absolute value of this expression. So that if you have a negative outcome from here, this symbol converts it to positive. If the two lines are parallel, then the angle between them is 0. In that case, the gradients are equal. That is, tan alpha is equal to 0 if the two lines are parallel. If the two lines are perpendicular, therefore alpha is equal to 90 degrees and tan alpha is equal to infinity. Tan 90 degrees is undefined. Hence, you equate the denominator to 0. If you transfer plus 1 to the right, you have it in this form. To express M1 in terms of M2, you simply divide both sides by m2, and you have m1 to be equal to minus 1 over m2. Therefore, two lines are perpendicular when the product of their gradient is minus 1. The two lines are perpendicular. Examples number 14. Find the equation of the line perpendicular to 3x minus 2y equal to 3 and passing through this point. Solution. The given line, we need to find its gradient. To enable us find the gradient of the line which is perpendicular to the given line. So let the gradient of the line required be m. From here, you write it in intercept form, that is y equal to ms plus c, for you to get the gradient. To do that, you simply solve for y. So let's transfer minus 2y to the right and 3 to the left. You have it in this form. Divide each term by 2. You have y to be equal to 3 over 2s minus 3 over 2. From here, the gradient is equal to 3 over 2. The gradient of this line is 3 over 2. Now, this line is perpendicular to the required line. So the two lines, the product of their gradients is equal to minus 1. Is equal to minus 1. For that reason, you have this gradient, that is 3 over 2 times m2 equal to minus 1. By the time you make m2 the subject, it becomes minus 2 over 3. Minus 2 over 3 as the gradient of the line required, which is perpendicular to the given line. Let the equation of the line required be y equal to ms plus c. Already the gradient of that line is minus 2 over 3. You come here and replace m with minus 2 over 3. You have it in this form. To form the equation, the intercept on the y-axis is needed. So we use this point where s is equal to 3, y is equal to minus 7 to get c. You come here and replace s and y. You have it in this form. 3 cancel 3. You are left with this. Transfer minus 2 to the left. You have this result. Therefore, c is equal to minus 5. Hence, the equation of the line required is coming here and replace c with minus 5. Multiply through by 3 to clear fraction. If you transfer these two terms to the left hand side, you have this result. Example 15. Find the equation of the line parallel to 6s plus 5y equal to 1 and passing through this point. Solution. If two lines are parallel to each other, their gradients are equal. That is, m1 equal to m2. Gradient of the first line is equal to the gradient of the second line. From the first line, find the gradient m1. So from the first line, once you know its gradient, it becomes the gradient of the second line you want to look for, which is parallel to the given line. From here, to get the gradient, you write this equation in the gradient intercept form. That is y equal to ms plus c. You do that by solving for y. When you solve for y, you have this result. So the given line, its gradient m1 is equal to minus 6 over 5. And because both lines are parallel, the second line, its gradient is the same as the gradient of the first line. Let the equation of the line required be y equal to ms plus c. You replace m with minus 6 over 5. You have it in this form. You need to solve for c using s equal to 4, y equal to minus 2 in this equation, and you have it in this form. If you multiply minus 6 by 4, you have this result. To make c the subject, transfer this term to the left. You have it in this form. If you find the LCM, you have this result. And finally, you have 14 over 5. Hence, the equation of the line required is coming here. You replace c with 14 over 5. Multiply through by 5 to clear fractions, and you have 6s plus 5y equal to 14. We are trying to express these results like the line given. So the two lines, this and this, are parallel. Example 16, find the acute angle between the pair of lines 4y plus 3s equal to 2 and s minus 2y equal to 3. Solution: to find the acute angle between the two lines, we should recall the formula of angles between two lines and rewrite the equation in gradient intercept form. Such angle is given in this form, where m1 is the gradient of the first line. To get that gradient, you rewrite line 1 to be in the form of y equal to ms plus c. When you do that, you have this result. You simply solve for y, and you have m1 to be equal to minus 3 over 4. Line 2, you also write it in the gradient intercept form by simply solving for y, and you have it in this form. m2 becomes 1 over 2. Therefore, tan alpha is equal to m2 minus m1 over 1 plus the product of the two gradients. Minus minus is plus, plus times minus is minus. 1 times 3 is 3 over 2 times 4, that is 8. If you simplify the two parts, numerator and denominator, you have this result. and this result. So you divide the numerator by the denominator in this form. In division of fractions, division sign changes to multiplication, and the fraction at the right of the sign is inverted. So you have it in this form. 5 cancel 5, divide 8 by 4, you have 2. Therefore, tan alpha is equal to 2. To get alpha, take the inverse of tangent of both sides. You have alpha equal to inverse of tangent of 2. To 2 decimal places, alpha is equal to 63.43 degrees. End of lesson 7. There is every need for you to be saved if you are not, because the Lord Jesus Christ is coming very soon. Some will be taken and some will be left. Live righteously and be prepared. Goodbye.